Hello, hello. Hopefully you can hear me. It should all be working. If you can hear me, just say so in the chat. As before, just say hi so I know you're here. Give it a minute or two just to make sure we get a number of people joining. So if you're here, just say hi in the chat and let me know if you can hear me. That would help as well. And while you do that, I'm just going to copy this over. Cool. And kill. Beautiful, beautiful, beautiful. All right. Awesome. So you can hear, we've got a couple of people here so far. All right. So what I want to do is have a look at the assignment 3, and then I might come back a little bit later and have a look at assignment 2. Now, we haven't marked assignment 2 yet, so I can't really give any more feedback at this stage, but if there's any questions about it, because if you didn't do assignment 2 correctly, it's going to make it hard to do assignment 3, especially around the memory allocation and so on. So the other thing that I will mention about the assignment that we have seen so far is some people have decided not to use LATCS5 and Antici. As it says on the assignment, that is a requirement, and if you don't do that, you lose the marks for compiling, which is, I think, around 80% of the marks. So please make sure you're using Antici and you are compiling on the system. So in this week's lab, we did some file I/O, and we looked at audio files. Now, we can apply our file I/O to pretty much any type of file. However, compressed files are difficult, okay, because we need to uncompress and recompress them. And so we mostly are going to focus on text files and uncompressed data files. So we've done that already. We've done it in the lab, and we've seen how a file looks when we've got data in it. And it's fairly simple. Let me just create another layer. We have some kind of header information, and then we have the data itself. And this is uncompressed. Okay. If it was compressed, this would make the problem a lot more difficult that we did this week in the lab. But the data was uncompressed, so you could just read it and write to it really, really easily. You didn't have to do any calculations to compress or decompress it. Now, the reason that I've chosen to do bitmaps is because, once again, they look exactly like this, and you've had a little bit of experience with these. So with these, we have header information and then uncompressed data, which is really nice because we can just read and write to it like we did in the lab this week. All right, so first things first, this program will perform different operations on images saved as bitmaps. The extension is .bmp. The output files for the assignment are BMP, so you need to open the results on Windows or Mac OS using a suitable image editor. I do recommend Paint. I know it's very basic, but you can zoom up to the pixel level on Paint which means you can see what's going on at each pixel. And we'll talk a little bit more than that. Now, obviously, this assignment, I want to make it exciting for you. And so what would make it exciting is being able to use your own pictures. There is one little requirement that you need to do to make your images suitable, is that the width of the image times 3 must be divisible by 4. Okay, so the reason for this is we're not using padding in this assignment. So usually with bitmaps, you pad the image. So all you do is just get your width of your image, times it by 3, and then divide it by 4. And if that comes out as a number without any decimal places, that image is fine to use. Otherwise, just change the width a little bit until it's suitable to use. And then you can use your own images. Okay. So if you're interested in extending the problem such that you do have padding, we can talk about that later. So then it'll work with any image. Okay. And you just need to remember that it is actually a 24-bit bitmap. And as I said, Paint is a good tool for this because it allows that option. So when you're selecting which image you would like to save, if you want to use your own images, just make sure it's a 24-bit bitmap. Okay. All right. So let's have a look at, firstly, the operations that our program is going to do. I've just broken everything. Assignment 3. So I'm just going to download the example inputs outputs because I don't know where I've stored it on my computer. Actually, yes, I do. Whatever, I'll download it again. All right, so go away. Extract to display files in Explorer. Sure. Okay, so let's have a look what we've got. I've got luminosity, beautiful. All right, so what I'm going to look at first is the luminosity. And that's fairly simple in terms of its explanation. So we've got an image like this, okay? And all we want to do is make it brighter or darker. Okay, so here's a darker version of it. So we're just changing the luminosity. Okay, so if you haven't heard that word before, that's what it means. Remove channel means removing red, green, or blue from the image. So an example of that, actually, what I'll do is I'll leave the examples out of it because you can look at those yourself. Quantize is reducing the number of colors in an image. Okay. So this can improve storage if you wanted to go down to 6 bits or something like that. Inverting the image, flipping the image, and then cropping the image. Okay. Is that all making sense so far? If that's making sense, just say so in the chat, and then we'll continue into the more important parts of this. So I will copy the more important parts across now. Just say yes in the chat. As I said, this is interactive, and it makes it easier for me. Why does this have to be annoying? All right, so we'll move across over to here, and I'll get the next part of the assignment up. All right, so the very first couple of steps, basically you must, okay, this is a must, include the standard IO, the standard lib.h, and the string.h. So with this, you cannot use any other ones. Basically, as I said before, we want a level playing field. And so we don't want you using anything outside of these three so that everyone has access to the same things. Then we're going to add a macro, okay? Max file name size. And this basically limits the size of the file to 100 characters. The name of the files to 100 characters. The reason we do this is just so when we're inputting, we know what that maximum is going to be. And so if you are using your own files, don't create something longer than that. Now, common mistake time, there is no semicolon after this, and there is no equality operator between these two. Okay. So basically, you've got a macro. All it will do is we'll find this and replace it with 100. Okay, and you can use this wherever you like in your program. You can create your own macros if you need them. Feel free. Basically, the general idea is that anything that's not a counter, so I is 0 is a counter, that's perfectly fine. But anything that's a limit, it's a good idea to write a macro for instead. Okay, so that might be max colors or something like that. When you have literals in your program, so you've got a random 3 there, you can give it a meaningful name by creating a macro. And this doesn't use any more memory up. Okay, if you remember back to the last help session compared to using a variable. Okay, so it's a lot more efficient way of giving literals names. Okay, it's just by using macros. All right, then we get to the big chunk of things. So fit, yes it will. All right, so now we get to the big chunk, which is step 3, and yeah, just step 3. So here, what we have is 2 structs, okay? The first struct is very simple in that it has 3 basic data types, and that's it, okay? So we've got a struct, okay, with 3 cars in it, okay? So they're unsigned, okay, and we're not using them as characters, okay? This is important. A lot of students, especially ones that show up right near the end of the subject, they see this word and they're like, it has to be a character, has to be a character, has to be a character. It does not have to be a character, okay? So unsigned cars have a range of 0 to 255, all right? And so each of these will be between 0 and 255. And we'll have how much red is it? That's not a very good red. How much green is it? And how much blue is it? Okay, so for example, if we had all lots and lots of red and not much green and blue, then it'd be a very red pixel. Okay, and you can combine them to make different colors. Okay, and that's our struct pixel. We then have our image struct, which contains all our information about our image. The first one is the file name. So we want to keep the file name with the image data. We then have the height of the image, which is just an int. You could make it an unsigned int if you like, because it is always going to be positive. We have the width, and we also have the size. Okay. Now the size includes the header information, so just be aware of it. It's not just height times width. And then we have this interesting guy, and we'll come back to this a little bit later. So this is a double pointer to these guys. Okay. So it doesn't hold the address of these. It holds the address of something that points to these. And this is going to be critically important on how we do this. And this is the hard part of the lab. And we'll talk about this today if enough people hang around. Okay? Because if you get this, then the rest of the assignment's fairly easy. Without this, none of it's going to work. Okay? So we'll leave that for now, and we'll come back to this because this is pretty much the main part of the assignment. Yes, you've got a lot of functions, but really compared to this, this is more important than all of these because you can't do any of these without that working or understanding it. We then have our functions. So couple of things to note. I've broken them up into different operations. I'm going to skip the first 3 lots because I want to talk about this first, okay? Just to make sense of it. So I've got image functions and pixel functions. So image functions focus on the whole image, where pixels functions focus on the pixels within the image. And each one of these will basically have a matching one of these, except for the save copy and the print information image, because the print information image and the save copy doesn't need anything from the pixel level. It's just at the image level. Okay, so these image functions are going to be extremely similar to each other, and there's going to be a lot of copy paste here, and that's perfectly fine. Some of them vary a little bit because they'll have submenus, but a lot of it's very similar. So if you see these being similar and you're freaking out saying, oh, I've done something wrong, they're all the same, you haven't. They're meant to be similar. These, because we're working at the pixel level, should be very different. Okay, so moving back up to the top 3 things here. So the first thing here, we've got load and save. Okay, now loading an image, big thing to note is there is a pointer there. Okay, why is there a pointer? Because I'm loading, I'm scanning, I'm getting. Okay, remember with scan, we need to pass the address in because I don't want to pass a value in, because if I'm getting something, it makes no sense to pass the value in. Rather, I need to say, this is where I'd like to store it. Okay, so this is where I would like to store it. Okay, cool. And that's why that's a pointer, because we're loading here. Now, when it comes to saving or printing, basically, we don't need the address. We just need to say, here it is, take it, print it, save it, do whatever you like with it. Okay, so it's not a pointer in this one. Okay, so this here is not a pointer because I'm just passing it in. Okay, so just take this and save. All right. The freeing is a little bit more complex this time. And so we actually have a separate function for freeing. Because of this double pointer, it's going to be a little bit more complex. And because of that, we set up our own freeing function here. We then have this reallocate pixels. I'm not going to talk about this too much. This is the real challenge in the assignment this time. And it's the very last thing that you want to look at. Okay, so don't worry too much about the realloc. All right. Does that kind of give you a general gist of what's happening so far? And then we'll continue. So just say yes or put a smiley face or an emoji of some kind in the chat, and then we'll continue. I'll also change this setting. Cool. All right, so I'll wait till I get a couple of things in the chat, and then we'll go on to the next one. Just so I know you're all up to the same space. So if you're all up to the same space, just put something in the chat, and then we'll continue. I'll just wait, give you a minute to let that sink in. This part here, I can probably just do on the screen. Actually, what I'll do. Just a bit more about free function. Yeah, we'll get to that. We can't do that. Okay, so the free pixels function is not going to make sense until we do this. Or are you talking about the free function in general? What about are you talking about the free pixels function, or are you talking about the free function? Not in general. Okay, yeah, okay. So not in, okay, so free pixels we can't talk about until we understand this, because we haven't understood the pixels yet, okay? This is a complex function until we understand this, okay? So we're gonna go through this first before we talk about the free pixels, okay? If you are already up to that, and you have been doing the free pixels and it's not working, either you're doing it in the wrong order or you've corrupted your memory. As we said in the first assignment, if your free doesn't work, you've corrupted your memory, and that means that your memory management doesn't work, and that was the big part of the assignment. Okay, a question. Okay, so yeah, okay, because there's no, you can't have a dot in a variable name. And you're scanning for a string, so you need to declare a buffer to store that information. So I'll just answer this question about next week's lab because someone's starting it. So last week's lab, if we want to store a string, we need to create a buffer for it. So let's just call it S buffer 100. And now we can store a string. Scanf, probably a printf beforehand, %s, S buffer. Okay, done. Okay. And then your F open would have a file pointer, and that would be an F open, S buffer, and then whatever type you have there, and then an if statement to check if it's valid, like we did in last week's lab. Okay, hopefully that answers your question. We'll come back to that a little bit later, but I'll just get that out of the way for now. All of this stuff is last week's lab, not this week's, in terms of the content. So, all right, so let's get back to the assignment. All right, so we have got a few people here, but I'm just waiting for some confirmation that we're all up to the same point. So if you're up to where we are right now, just put something in the chat so I know that you're up to this point, and then we can keep discussing the assignment. And hopefully that answers your question about the error. Because, yeah, we've never had dot as our variable name. We have used it for structs, but that's about it. Yep, cool. All right, so some of the constraints. Once again, there's only 3 headers you're allowed to use, which are standard IO, standard lib, and string.h. That also means that there's stuff in them that you need to demonstrate. You can't use goto. Now, the one that I've highlighted, okay, is formatting can be changed if the user interface is user-friendly. So feel free to be a bit creative with the user interface. You can make it pretty. You can put stars around it. You can do what you like in this assignment. We were very strict in the first couple of assignments just because we needed you to see format specifiers, certain things from the marking perspective. This assignment, we've already marked format specifiers, so we don't really care. So you can make your menu as pretty as you like, as long as it's user-friendly. Okay, you can change the text, you can put stars around it, you can change the colors, you can do it if you know how. You can make it look however you like. Okay, so you don't have to follow it perfectly, as long as it includes the correct menu options. So that's one big change from the previous assignments. So feel free to be a bit creative there. Once again, there's a student number, there's a password. It must be done using Antici, okay, and compile on LATCS5, okay. All your assignments will be compiled on that compiler. If they don't compile on that compiler, then you lose the marks for compiling. As simple as that, okay. It's on the assignment and so on. Code must not crash or have the potential to crash due to Stack Overflow or segmentation fault. So if your program has the chance of crashing, then we will take marks off. Sometimes it's hard to analyze that, and that's why you need an understanding of what your program does. A good hint is if free fails, your program has the potential to crash, okay? If free fails, then you've got something very, very wrong in your program and you're accessing illegal memory and your program has a chance of crashing, okay? I noticed a couple of people commented out there free saying it doesn't work. No, the free works, your code doesn't work, okay? And it basically means you've corrupted your memory somewhere between declaring malloc and freeing. And that's why it can't free, because it's corrupted. Okay, so it's not the free that's the problem, it's your code that's the problem. Types should be used appropriately, as always. Variables should be limited to an appropriate scope. I noticed a lot of people have been doing that really well, and that's excellent to see. Commenting as usual. Okay, cool. Now, the other one. This one here, some students really struggle to read this. The code should be around 400 to 600 lines of code without comments. There's no bonuses here. If your code is significantly in red larger, so if it's 1,000 lines, then you've probably done it wrong. If it's 800 lines, maybe you've made it a little bit redundant, but it's still probably right. If you've made it 900, you probably need to think significantly larger. It doesn't say it has to be below 600. You could have 800 lines and it could be perfect. Okay. You may be doing a lot of debugging and things like that, or you may be making it a really nice, user-friendly interface. It does not say that it has to be under 600 lines. Read this. It does not say that. Okay, I've had a couple of students saying that their assignments greater than for the last assignment, my assignment's greater than 400. Will you mark me down? No, read the question. It doesn't, read the hint. It doesn't say it has to be below. It could be perfectly fine. It might be an even better solution being longer. Okay, so it's only if it's significantly larger you might want to reconsider. Okay, usually if it's too long, it's a lot of redundancy, so you're repeating things too many times. Okay, but sometimes it's a fine solution. Okay, if you're confident with your solution and it's a little bit longer, it's 700-800 lines, fine, submit it. It's probably right. Okay, cool. So don't get confused by that. All right, where are we at? Okay, so I'm just going to get the document and put it over here. So rubric, once again, go to no student number, no password, includes files out of these three. Okay, so you've got 3 this time. Now, once again, with this assignment, if it doesn't compile, you automatically lose marks. And because everything's a function, you should not lose the marks for main. Because if one function doesn't compile, you just comment it out. Okay? And the way you should be doing this is a function at a time. Because if you write a whole heap of functions and all of them don't compile, then all of them you don't get marks. If you get main working and you get one function working, you get all the marks for that. Okay? So really think about your marks and also just professionalism in general. Okay? So you can go through and have a look at the marking guide. There's the general marks as well as usual, like indentation, variables named appropriately, limited scope, variable types, unsafe behavior, and comments at the top of your code. Okay, cool. Now, the last bit is this. Okay, this is your functions list, and it's also in a folder on LMS. These are all hyperlinks, so you can just double click on them and they'll download the particular function for you as long as you're logged into LMS. Okay, so the first one's going to be main. Okay, so what I'll do is I will download that and we'll go through it. Right, if you're still here, just say so. If it's making sense, just say so. Hopefully this is helpful, and we'll have the first part of the assignment done, and then the rest is fairly just a bit more of experimentation. So let me copy this so that I can draw on it. Makes sense? Beautiful. Sorry, I've lost what I wanted. Let me just do one more thing. The time up to 20:55. Cool. All right. So this first part is main function. This should be fairly easy. It's based on assignment 1 more than assignment 2. And this is kind of the reverse logic of assignment 1. So in assignment 1, if the user entered something incorrect, you kept looping. Okay? We're here to keep looping until the user decides they want to quit. Okay? Now, this is a menu-based system. Okay? And so it happens one or more times. So what kind of loop would be appropriate here? So one or more times, what kind of loop would be suitable? Yeah, so do while would be the suitable one. All right, so basically we have main, we have our student number, we have our password. Our password's retrieved from the server this time. Make sure you get it independently because they're logged, okay? And the time that you get it is logged, okay? So make sure you get it. The ones on LMS are logged as well, but this is a bit easier for me. Then you're going to create this menu, okay? As I said, you can make this pretty as you like. You can add stars around it, okay? For example, or you could make all this tabbed instead. Feel free to make this look however you like. You can change this from image menu. Maybe you could put some lines next to it or something, whatever you like, okay? You can make this your own. Make it stand out from the rest of the other students, okay? With this, you need to print a menu, okay? So you're going to have your do while as mentioned, okay? And this do while is going to be kind of long, okay? And as it says, where is it? So I don't even know where it says it, but it says basically, based on the menu, if they enter -1, then it quits. So it continues while something is not equal to -1. Okay, you can work out how to write that. You'll need a variable for that as well. We then just have this big block of print. Okay, lots of prints. Okay, and as I said, make it pretty. And that'll be this part here. Okay, now you'll notice also it says if they enter something invalid, then you don't have to print out an error message or something. Just show the menu again. Okay. Then you've got if the user selects a valid entry 1, 2, 3, 4, 5, 6, 7. Well, that's exactly what we're about to do. If the user selects a valid entry 1, 2, 3, 4, 5, 6, or 7, then the appropriate function should be called. Okay, and there's a couple of examples. Oh no, there's the whole list here. I've cut off the bottom when I've copied this across. So I will get the rest of this. It's D, it's E. So I've got the bottom now. Look at that. That's beautiful. All right. So basically, based on what the user enters, so we need to get the value from the user. So get value. That can just be a scanf. From there, basically, we have if, else if, else if, else if, and calls to functions. If, else if, and so on. Okay, so if our value is 1, else if, and so on. All right. pause. What? I'm confused. Okay. You don't need an else because we don't want to print anything if they enter something invalid. I see. Lining them up. Yeah. All right. Cool. Okay. So we've got all that. Yeah. And the other thing is that inside of this, you're going to have function calls. So these are going to be all your image functions. So print image function, etc. Print image function. You can pass your variables that you need and so on. Okay. Now with this, okay, once you write that, you're going to get an error saying that the function doesn't exist because it doesn't. It's not below main yet. What I recommend you do is below main, write. So what have we got? Where's our function list? That's not it. Yeah, so I'll just take one for example. Save image copy. Okay, just write the functions and put a printf in them. Not yet implemented. Okay, so if you accidentally call it, it'll just print to the screen, not yet implemented. If it returns something, just return 0 and just print that not yet implemented as well. Okay. Basically, this will just help you to be able to call the functions and check that it calls the right one. So you can put a number in here or something, but also it'll give you a reminder saying it's not yet implemented yet. Okay, and it will still compile. Okay, once again, we want to maintain code that compiles. Are we all good up to this point? So this shouldn't be too difficult. This is very, very similar to assignment 1, except for it's a lot bigger. And we're calling functions in here rather than if it's invalid, print out something and print out a message. We're calling a function. Okay, so it's going to be a do while, and we're going to call all of these functions. Now, with the functions that we're calling, we don't even have to actually pass anything. So it keeps main pretty isolated from the rest of the functions, which is actually kind of nice because in the labs and the other assignments, main has been very interconnected with our other functions. But what you'll notice with this particular program and the way that I've specified it to be written is main just has a menu. It doesn't interact with the files whatsoever. It has nothing to do with the files, which is kind of good from a testing perspective because you can just isolate particular functions and just focus on them. You don't have to see their effect on main, which is controlling everything. So this is one way you can design your programs in the future so that you don't have such a heavy load on main. Okay, main just controls the menu and that's all it does. And it sends the responsibility off. All right, so once we've done that, then we get to the load image. And the load image is probably the biggest one and probably the hardest one to do. And it's the very second one. But once you get that, everything will be good. So what I might do is I might actually switch gears and just talk about 2D memory. So what I might do is I might just open a new one. So I'm going to talk about it in a general sense, and then we'll go back to the assignment and we'll do it in the assignment. Okay. All right, so what I'm going to do, I'm just going to take a quick 3-minute break. I'm just going to grab a drink, and then we'll talk about. So if anyone's behind, just skip ahead 3 minutes or whatever. Skip to where we're live, because this will be the important part. 2D dynamic mem. Okay. All right. Give me a second. All right. Hopefully you can still hear me. Hopefully you're still here. All right. So what I'm going to do first is just a quick talk about two-dimensional, and then we'll talk about two-dimensional dynamic. Two-dimensional is not very exciting. So we've done one-dimensional arrays. So int a 4 and initialized it to 1762. Again, we've been able to access and retrieve information and store information into that. That's not too complex. We can also do static two-dimensional arrays, so where we know the size. Okay. Why is it doing that? Sorry, the pen's playing up. All right, so with this here, this gives us 3 rows and 4 columns. All right. So we just write this like this. And I'll write it on multiple lines so you can see the columns quite clearly. All right, so let's just make up some values. 1, 7, 6, 2, 8, 4, 3, 1, 6, 2, 4, 8. Okay, so that's a two-dimensional array. That's it initialized. Put a semicolon there. And then if I wanted to get the value from the second column and third row, okay, so I wanted to get this value, I would just write, let's say I want to print it. So I'd do printf %d b. So I want that one. So it's going to be row 2. Remember, it starts at index 0. And I want the second one. So that's going to be index 1 in terms of the columns. So that's our retrieval. We can also do storage as well. Okay, so that's two-dimensional arrays. They're not very exciting compared to one-dimensional. But we'll talk a little bit more about them when we get to the pixels, because we're going to have to iterate through two-dimensional arrays, which isn't too interesting, but we'll finally be allowed to use the variable name j. Okay. Does that make sense, or do I need to do some more examples with two-dimensional arrays? Does the basics of two-dimensional arrays make sense? Because we're now going to make it very complex. So just say yes, or put a turtle in the chat, or some kind of little animal, so I know that you are up to where I am. Where is the turtle? There's the turtle. So if you are watching along, please use the chat. It tells me where you're at, and it tells me that you're engaged, which is very useful information for me because I don't like talking to a wall. All right, so now we get to 2D dynamically allocated memory. Now, this is significantly more difficult, and there's quite a number of ways to actually do this. We're going to do this the easiest way, in my opinion. It doesn't mean it's the best way. The ways depend on the situation and depend on what you're actually trying to achieve. But this is one way to do it. If you have a look at week 12, I actually give you some of my code, and you can see another way of doing it, which involves one malloc. This will involve a lot of mallocs. Okay. So what we're going to do here is let's just do this. Actually, yeah, let's do it this way. So let's say I ask the user. So let's say we've got int, not width. Let's just call it rows and columns. Rows, int, columns. Okay. And then I ask the user, printf, how many rows? Okay. And because I've asked that question, it now makes it dynamic. Okay. And I'm going to copy that. And I should have copied the scanf as well. Oh well. And I'm going to ask them how many columns. Okay. So we have both dimensions are dynamic. Now, if one dimension is dynamic and the other isn't, there is even another way you can do this, but we're not going to worry about that. Okay. and then just the scanf %d address of rows and scanf %d address of columns. So this isn't very exciting at this stage. This is all stuff you've done before. So this just gives us the fact that this is dynamic. We do not know before the program what the user is thinking. Okay. They could enter 4 rows, 4 columns. They could enter 40,000 rows, 40,000 columns. Okay. We don't know what they're going to enter. All right. And that's important. Okay. Because that means that it is dynamic. All right. So the way that I'm going to do this will involve a double pointer. Okay. And as I said, there are other ways to do this. And so if you go on the internet and Google this, you'll get all different kinds of answers. And most of the other methods are a little bit more complex. Some of them only involve a single pointer, but that's actually a lot more difficult, okay? Because you're basically grouping all of your memory together. So what I'm going to do first is let's just pretend that the user here is going to enter 4. That's a 5. 5 then, and let's say 6 columns. Okay, so 5 rows, 6 columns. So the first thing that I'm going to do is I'm going to, now this is going to be an array of ints. Okay, we'll talk about our structs when we talk about the assignment. Okay, and I'm going to make this a double pointer. Okay, and I'm going to call this variable, let's say, array. Okay, or maybe I'll call it 2D array. I can't start with the, so I'll just call it 2D array. Okay, so this is going to be my 2D array. Now, before I go anywhere, remember that with an int star, okay, we can write a square brackets, okay, because all it's doing is dereferencing and adding I. So with a two-dimensional array declared the way that we're going to now, we can use the square brackets, which makes things super easy, okay, once we're finished. This part's a little bit difficult, but we'll get there. Okay. The first thing I'm going to do now, I'm actually going to do it on one line because I much prefer doing it on one line. So I'm going to go. I'll add the typecast just to make it clear. Malloc size of int star times rows. Okay, so what this has done here, okay, in this, what it's done is we now have a variable called 2D array. Okay, actually, let's do proper box and pointer diagrams because I think that might help people. So we've got 2D array. It's an int star star. Okay. And we've created row number of pointers. Okay, so I've got a bunch of pointers here. Okay, this can go anywhere. It can go in a function, it can go in main, it can go wherever you like. It doesn't make a difference. It's like putting scanf inside of a function or not putting it in a function. It doesn't make a difference. So it could be in main, it could be in a function, it could be, well, it has to be somewhere that's procedurally accessed. So it's either in the main or in one of your functions. And we've got an array of int stars. Okay. As I said, this isn't the assignment yet. This is just an example. Okay. So we've got an array of int stars. All right. And because malloc returns a pointer, this pointer is pointing here. Okay. What we're going to do now is declare a counter. So I'm going to declare I. Okay. And I'm going to create a for loop. And I'm going to count I starting at 0, I less than rows, I plus plus. Inside of this, I'm going to write 2D array, and then I'm going to add the index. Okay. So at index 0, it's talking about this pointer. Index 1, it's talking about this pointer. At index 2, it's pointing about this. 3, 4. Okay. Does that make sense so far? Okay. And what I'm going to do is I'm going to use, so I'll move that over across and we'll come back to that, is, oh, go away. Don't care. Okay, what I'm going to do is I'm going to malloc a set of ints. Okay, so malloc, this time it's going to be size of int times our columns. So what does this do? Let's move this guy back down over here. No, it's not empty. There we go. You're annoying me. All right, so we're going to go through this step by step so you can see what's happening. All right. So basically what we've got here is we've got our first malloc, which created a set of pointers. We then get to this for loop. And remember, the user entered rows of 5 and columns of 6. So first iteration, we're talking about this one here. Okay, we've got 2D array I. It's not a 1, it's an I. So if anyone questions that. And it's going to point at something because we've got a malloc. And what it's going to point at is 6 times int. So it's going to point at 6 ints. Okay, 1, 2, 3, 4, 5, 6. Okay, and all of these are now ints. Okay, so it's just malloced 6 ints. We then iterate and we move to 2D array 1. So now we're talking about this one, and it's going to do the same thing. Okay, so now we've got another set of ints. And then from there, we're going to do the same thing once again. Okay, because we go back up, I is now 2. So we're talking about this index, and it's going to create another set here. Okay, and so on until it's done. No, not that. What have I done? That layer. You are really annoying. There we go. All right. So we have this here. Now we can clearly see that this has 5 rows, 6 columns to store our data. And that's how we create a 2D array dynamically. Now, what's great about this methodology is that now, okay, let's say I want to store something here. All I do is go 2D array, row 1, column 2, 4. It has a 4 in it. Okay, so I can just use square brackets and everything will work out perfectly fine. Now, does that make sense? Okay, let me just check that it makes sense and then we can talk about the next thing. And then we can go back to the assignment and do the exact same thing with the assignment. So let me know if that makes sense. You can put a turtle in the chat if it does, or a sentence, or a statement, or a joke, or whatever you like. Cool. All right. So we now have a 2-dimensional array. How to use it is fairly self-explanatory. Okay, we can use it on the left-hand side or right-hand side. Okay, now let's say that you've gone ahead. Well, let's say you've gone ahead and you're finished with your array. And this is really important. The order that you do this in, this is freeing your array. Okay, and this goes back to one of the questions that someone asked right at the start is, how do we do this free? Because it's actually a little bit more complex. Because what we've got to free this time is each one of these, okay, and this, okay, because every single one of these had a malloc, okay? Now, the biggest mistake you can do, and the most common mistake you can do, is you free this one first, okay? If you free this one first, you've lost your reference, and so you can't free these ones, okay? So that's a very silly mistake to make, and we don't want to do that, okay? So you need to make sure you free these first. Now, how do we free these first? Okay, so this is going to be our free. Okay, you're doing this in a function, but I'll just do it here to show you the concept. So obviously we need a loop and we're iterating over these. So we'll introduce an I variable. We've actually already got one, but just pretend this is in another function. Oh, we're about to run out of room. So let me just make the canvas a little bigger. Kill. All right. So what we're going to do is we're just going to iterate and free each one of these first, and then we'll free the big one. So for loop, I starts at 0, I less than rows, I plus plus, blah. And then from there, we're going to free, and we're going to free, what are we going to free? 2D array I. Okay, and then once we've freed every single one of these, so this will go through and go freed, 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 freed. Okay, and if you haven't corrupted memory, that should all work. And then we should have another free at the end of that, and free 2D array. Okay, and that will free this guy. Now, what you'll notice is this free, okay, this free here is just the backwards of the malloc. Okay, so we did this first before, and then we did the for loop, creating the memory for each one. This one, we free the memory first of each one, and then we free the big one at the end. Okay, so it's in the reverse order, because if we free this first, we won't be able to access these other ones, and you'll get, well, your program will definitely crash. All right, so hopefully that made sense. Let's jump back into the assignment. Now you notice that we haven't used J yet as well. So where's the assignment? The assignment should be somewhere. There it is. But I forgot what we were doing. Oh, maybe I need to zoom out. Let's zoom. Was it on this sheet? Oh, it might have been on this sheet. Okay. Or maybe I haven't put it anywhere yet. Okay, we'll just do it on this one. All right, so we're on a nice new canvas. All right, so what I'll do is I will copy across the function description of our load image. All right, so this is our first image function, and this is one of the most important ones. As I said, with the big list before, you had load and save. You can't really do anything without these, okay? If you can't do one of the other images, that's fine, okay? So if you can't do the luminosity, you can skip it and keep going. This one you can't skip, okay? Because if you skip this, you won't be able to load the image to do anything with it, okay? So this one is fundamental and core. All right. Now, I've mentioned here, when implementing this function, keep in mind that it accepts a pointer to the struct attribute image. Now, I did make one change to this just to make it a little bit easier for you. In the original list of function prototypes, I just wrote image, but I've changed it to image pointer just because then you don't get confused between which one's a pointer or not. So it is a pointer. The names of your prototypes, so the names in the parameter list for your prototypes don't have to match your actual function as well, just so you're aware. That's why we can just delete them if we want. The other thing here is this function returns a 0 on successful execution, else a 1 if the image cannot be loaded. So this is something that we did in the lab this week. We returned different values depending on if it was successful or not. And we're basically going to return a 0 if it worked and a 1 if it didn't work. So that's going to be super helpful because our other functions will need to know that information. All right. So, all right. So ask the user to enter a file name of the image to load. Now, if I'm going to ask for something, let's say I was going to ask for your height, okay? And I'm going to use scanf. Before that, I need to declare where I'm actually going to store that information, okay? So that's important, okay? And you can't get away from that. You still need to do that. But what you'll notice is we actually already have somewhere to store it, okay? And that's because we've got this pointer, okay? So inside of our function, okay, this function is actually pointing to a valid pointer, okay? And inside of that, there's a file name that's empty, all right? So we actually already have the place to store our data. So I will give you this one because this one's kind of a little bit difficult, and it's just the first one, so I will make this a freebie. So ask the user, so printf, blah, 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 user, give me the value or else. And then we're going to get the value. Now, it's a file name, so it's going to be %s. Where we're going to store it is going to be, we've got this image pointer, okay? And what we can do now is we can get the file name. Remember, the file name is one of the, where is it? It's over here. File name is one of the members. Okay, and it's a string. Okay, now why did I use this arrow? Because we're dereferencing a pointer. Remember, it's a pointer. Okay, so I can get the file name and store it directly into my struct. Okay, and this is similar to our lab where we did structs, and I think it was the calculate, or it might have been the print. I can't remember which one. One of them we passed in a pointer, and we had to access everything using the little arrow. Okay, and this is basically the same thing. Okay, so we're accessing everything with a little arrow. Where in the save one, we'll access everything with the dot operator. All right. So the next thing is create a copy of the file name and store appropriately using string copy. Okay. So this time we do need somewhere to store it. Now, if we are going to basically make a copy, we need something that's at least the same size as it. But you'll notice that we're going to add an extension as well. So what I'm going to do is I'm going to create a copy, and well, I'm going to create a place to store the copy. Sorry. So I'll just call it file name copy. Okay. And we had that macro. Now let me remember what that macro was. Max file name size. I'm just going to steal it because it saves me typing. Hopefully it's on the right layer. Let me just merge everything. Merge visible. Right, so I'm just going to put that in there. And for me, I'm going to add 4 because I know that the next line requires an extension to be added. If you forgot the 4, it's not a huge issue. Okay. And then we're going to create a copy using the string copy function. Okay. So let me get up the definition. So it's a good idea to be able to read some of these definitions. So I will put this here because quite often you will need to read descriptions because you'll need to access a lot more than we can just teach you in one subject. There's so much code out there that you should be able to read a description. So this is the description of string copy, okay? And basically it returns a pointer, okay? Which is a pointer to the destination string. That really doesn't matter to us, okay? Because the destination is also in the parameter list. What worries, well, what concerns us is more the parameters for string copy. So destination, this pointer is the destination array where the content is to be copied. And then source, this is the string to be copied. So we're going to take our source and we're going to copy it into here. So we're going to have something like string copy. Our destination is going to be fn copy, and our source is going to be this one. Okay, that's just our file name. Okay. Okay. So that's how we can make a copy of a string. Okay. You cannot just use that. It won't work. Okay, because they're both pointers. You're just copying the memory address. All right. Then you are going to access, you're going to add the extension .bmp. Okay. So here you're going to need another function. So this is going to be string cat. Now, the cat does not stand for the feline cat. What it stands for instead is concatenate. So anyone that's done a little bit of object-oriented programming at La Trobe's probably heard this term a million times before. But we also use it with strings. And basically it means put two strings together. Okay, concatenate them together. All right. So its definition looks something like this. Okay, so the destination, this is a pointer to the destination array, which should contain a C string and should be large enough to contain the concatenated resulting string. This is the string to be appended. So let me give you an example. I'm on pen. Yeah, I am. So let's do car A, and I'll make this big because we need enough space such that we can append to it. So I'll do hello, and then I will do another string. Actually, I won't even bother doing another string. And I'll do string cat. Okay. A by. So it could be another string in a variable, or it could be just a literal. And so now A should have hello by in it. Okay, so I've just added that to the end. Okay, and that's all a concatenation is doing. It's just adding it to the end. It doesn't have to be a literal. It can be another variable as well. So it could have been something like that, and then I could put B in there, and then this would say hello no. Okay, so string cat, that's how we use it. You're going to have to add .bmp to the end. I think you should be able to work that out. Cool. I think that's pretty cool. Pretty cool, pretty cool, pretty cool. All right. Open the image. Okay, so open the image using the file name with the extension. So that's your copy version, not your original version. So basically inside of the struct, we're storing the name without the extension. Okay, so let's say your file is puppy. You've got an image of a puppy, and the file name is puppy.bmp. The puppy will be stored in here. In the copy will be puppy.bmp. Okay, so that one has that, where the copy has the extension on it. Okay, cool. All right. Where are we? So open the image. This is just F open. Don't forget you need to save the file pointer. Don't have F open by itself on a line. It's just pointless because it's just opening all that image and you have no access to it. So don't forget you need to create a file pointer. Okay. F open. And then whatever goes in here. Okay. And then blah. And what are we doing? Open the image for reading. Okay. So you need to put the reading option here, which we did in this week's lab. We did both reading and writing in this week's lab. So you should know what goes there. And this should be the copy with the extension. All right. If the file cannot be opened for any reason, print to the screen, file cannot be opened, and return 1. Well, we did that this week. That should be very easy. All right. I'm going to take a little bit of a break for 5 minutes. I won't be very long. So go get your drinks or whatever you need to do. And then we'll go have a look at fseek. And then this is all stuff from this week's lab, and then we'll look at this. Okay. So let's just do 5-minute break. I'll be right back. All right, we all still here. Something in the chat, something interesting, something weird, whatever you like. I'm going to. Wish it made it bigger. Pineapples. Cool. All right. Awesome. So let's get rid of this stuff. All right. So where were we at? Okay. So we just opened the file. And we have a pen. Okay. So now we're going to have a look at fseek. Now, fseek is something that we haven't done yet. I'll get the definition up because I think it's good to start having a look at the definitions because this is something you'll have to do in the future quite often. It's looking at APIs and using other people's or standard functions and being able to read the documentation. As you know, documentation is pretty important. So let's copy this across. All right. So fseek. So fseek, basically what it does is, let's say you're a position in the file. Okay. So you've got some file and it's got hello. It's actually more likely to be binary data. Let's just do binary data. So let's say we've got the hexadecimal numbers A, B, 1, 3, F2, 8, 7. Okay. And you've done an F read and you're up to this point in the file. Okay. Remember that file pointer is moving. All right. Now, if I wanted to skip the next two, there's two ways I could do it. I could just read the next two and just discard the data. But another way is to seek. And this allows us to move, okay, backwards and forwards through the file. So maybe I need to read something again and I need to go back. Or maybe I need to go to a particular position in the file. So fseek allows us to do that, okay? It returns an int. It returns 0 if successful. You're going to see this quite often. There's a very good reason for it, which we can talk about later. Also returns a non-zero value, okay, if it wasn't successful. Okay. Now, the first argument is the stream. Now, stream, file pointer, same thing, okay? File pointer is the same thing as stream. Okay, so if you see the word stream, that's what it's talking about. And that's why it's a file star. Okay. Offset. So the offset is basically how many bytes you'd like to move. So I'd like to move 2, I'd like to move 4 bytes, I'd like to move 8 bytes, whatever. Okay, so you can specify how many bytes. And then this great word, whence, is from where. So most often you're going to want to move from the current position, okay, which is seek current, okay. But if you wanted to, you can, or you could seek from the end of the file. If you're seeking from the end of the file, then this offset should be negative, okay, because you have to go backwards, okay. So let's have a look at this fseek. So where are we? Skip the first 2 bytes using fseek. So fseek, we won't worry if it's successful or not. We'll just assume for now. You can implement that if you like. The first argument is our stream or our file pointer. Our second argument is going to be, sorry, let me just check something. Cool. Our second argument is going to be how many bytes we want to move. So it's going to be 2 bytes. And then whence is from the current position. So this uses these constants, okay? And you're going to see this in lab 12 as well, where instead of a value or a variable, rather you pass a macro that represents some kind of value. Okay, so fseek, from our file pointer, we want to move to from our current position. Okay, and that's all our fseek is. Then read the size of the file, okay, using fread. Okay, we're passing the address in. Remember, with fread and fwrite, we always pass the address in, and we are going to store that in size. Okay, so in terms of our struct, we're going to store it. Oh dear. We're going to store it some. Why can't I run anything? It's probably, yeah, it is. Okay, so we're going to store it here. Okay, now remember that we have a pointer, so we use the little arrows. Okay, we'll be reading 4 bytes. Okay, 4 bytes. We're only reading one of them, and we've got our file pointer. I've called it FP here. I've called it F pointer here. Whatever you want to call it, it's up to you. I don't really mind. Skip the next 12 bytes of the file using fseek. You know how to do that now. Read the width of the image by reading the next 4 bytes and store appropriately using fread. So this is going to be very similar to this line here, except for instead of size, you're going to be storing it in the width. Same with the next one. Read the height of the image by reading the next 4 bytes and store appropriately using fread. Then skip the next 28 bytes using fseek. So we're not using a lot of the header. We're actually ignoring a lot of the header for this program. And this is what makes bitmaps really good. But as I said, there is that thing we need to consider in that the image, if you want to use your own, you need to make sure that timesing it by 3 is divisible by 4 for the width. The height doesn't actually matter. Okay, it can be any height. All right. Now what we want to do is we want to dynamically allocate the memory for the pixels. Okay. So this goes back to what we did before. All right. So first, what we want to do is dynamically allocate for our pixels. Now, this is a little bit more difficult because these are struct pointers, but the methodology is exactly the same. Now, there's 2 ways you could go about this. You could do all this and then store it, or you could do the storage in one go, because at the end of the day, it has to be stored here. So what we can do is we can store it directly there by using our image underscore pointer arrow pixel. And from there, if we want to create this, okay, we want to return a struct pixel star star. Okay. And then in here, we're going to have our malloc, just like we did with our ints, but this time it's not size of int. It's going to be size, it's not going to be size of int star. It's going to be size of struct pixel star multiplied by the height. So the height is the number of rows, okay? And that's just going to be image arrow height, because we've already stored that, okay? And hopefully I've got enough brackets there, and that will give us this, okay? All it is doing is creating an array of pointers. Okay, so we've got this here, and then we've got an array of pointers. Okay, they're not pointing anywhere yet. We need to dynamically allocate that. So they're uninitialized at this point. They're a little bit dangerous, but we've done that step. Okay, let me copy the next part of the document. All right, so actually it's I'll copy it anyway. All right, and then we'll talk about the next part. I've lost my image now. There it is. All right. So this here, you can quite clearly see this is very similar to what we did before. So we've got that main pointer, which is this one here. And then we've got this row pointers or height pointers in this case. So we'll call these height pointers. Okay. And then we're going to go through a for loop and we're going to create the width for each one of these. Okay. So the hint here is then we iterate hint for loop and allocate memory for the pixels for in each row. Okay. So our example here is a height of 3 times 4. And you can see quite clearly there's a height of 3 times 4. Okay, so we are actually creating this. So you're going to need some iteration variable like I. You're going to have a for loop. And then inside of this, you're going to have to do another malloc. Okay, but iteratively. So this time it's going to be image pointer, arrow, pixel with a square bracket, I, and then you're going to have your malloc. Okay? And you need to work out what goes there. Okay? So the first things first is, let me see if I can hide some of this. Okay, so you need to work out what goes there. The first thing is going to be your typecast, then your malloc, then your size of something multiplied by your width. And you need to access your width from your image pointer. Okay, so I'll leave that for you to solve. All right. Think about what you want the size of. Okay. As a clue, whoa, this is getting messy. But as a clue, let's just move over here. When we did malloc before, okay, size of int times n. In the last assignment, remember that the size of whatever's here should be one less star than's here. And this star and this star should match. Okay, they should match, and this should be one less star. All right. So you need to work out what type is this. Well, it's one of these. Okay, it's a struct pixel star. Okay, so you should know what goes there, and you should know what goes there. Does that make sense? Okay, and that will give you your dynamic memory structure. Once you have this, you will have a lot of power in the assignment, not to rule the world. So if that made sense, or is starting to make sense, or you want to give it a go, but let's just, and you want to just continue. Otherwise, if you've got a question, say so. Otherwise, cool on. or potato, or tomato. Or strawberry. All right. Now, with this, we saw before that we can now access individual spots in our array. So I should be able to write now image arrow pixels, let's say 2, 2. Okay. And that's okay. But the problem is that our pixels are not ints. So I can't do becomes 2 like our int example. Rather, it can be red, green, or blue. Okay, so if we go back here, it can be red, green, or blue. So if I wanted to make my pixel at index 2 and 2 a little bit more red, I could do something like set it to 255. Okay. This is going to be my y coordinate. This is going to be my x coordinate. Okay. So I can change things wherever I need. Okay. Now, for most of these tasks, we don't really care about an individual specific pixel. Rather, we're going to go through every single pixel. Okay. And this is the way we're going to access it with a pointer. Oh, I should have said image pointer, sorry. Image pointer. Okay. This is how we're going to access it with a pointer. But if we've got an image and it's not a pointer, then we just use image dot pixels. And then which pixel we're talking about, and then the red and green. Now, at this stage, we've created this big structure, okay, and it's going to be massive, all right? Be aware of that, okay? And this is why, let me just grab it off LMS. On LMS, if you have a look down the bottom, there's this tiny 8x4, which is a small image for debugging. Okay. And I've included that. So if you save that, which I'm doing right now, and you open up in Paint, you'll be like, Matt's insane. There's no image there. But if you zoom up like 800%, what you'll notice is that there is an image there, and you've got 8 colors, and each are 2 pixels across. Okay, this is a great little image for you to test really basic stuff on. Okay, so you can play with this as much as you like, because when you go and open up, let's take Latrobe 2 for an example. Okay, when you open this up, there are lots and lots and lots and lots and lots of pixels. Okay, there are heaps of them. Okay, and this is going to be hard to debug. Okay, the Latrobe 3 one. Okay, same thing, but even bigger. Okay, so here you're talking about 1,900 times 700 times 3. Okay, so you're talking about a very large number of stuff going on. Okay, so keep that in mind. Now let me go copy the last part of this load image. Where the hell is it? Load image, there it is. All right. I was already there, damn it. Oh, well. All right, so. I've lost my chat. Lost everyone. All right, so create iteration variables I and j. Yay, we're allowed to use j. Okay. Now it says here you do not need to create I if you already created it in step 12, which we did. We created it up here somewhere. I don't know where, but we did create it. Okay, so if you've created I, you don't need to create it again unless you want to limit scope. Okay, so we can declare j. And what we're going to do here is, so we've got this image, okay, and each one of these has 3 colors. Okay, and basically what we want to do is we want to load in all this information. And so what we want to do is we want to read in. Now the order is important, and the order is not in terms of RGB, but it's in terms of blue, green, R. So it's actually backwards. So we read in the blue part first, then the green part. Well, would help if I chose green, and then red. Then we go to the next pixel. Then we read the blue, the green, and the red. And then the blue, green, and red. And then we move to the next row, okay? Or next part of the height, and continue with this, all right? Okay, so here we've got iteration, but we don't have single dimensional iteration, we have 2-dimensional. But you can see that this first row is just single dimension iteration. And so is this row, and so is this row. So basically it's iteration. No, there's no big or little endian because everything's a byte. So it's actually irrelevant because each of the colors are a byte. So little endian or big endian don't really matter here. Oh, you mean in terms of the color order? No, it's just bitmap. It's just how bitmap stores it. No, it doesn't have anything to do with big endian or little endian though. Because they're all separate bits of data. It's not storing the data in a different order. All right, so next thing is, it says iterate from 0 to the height of the image. So for I starts at 0, I less than image, pointer, height, I plus plus, blah, blah, blah. And this is doing our iteration down our rows. Now we just need to do single iteration across our rows. So for j, okay, so this is our j variable. Okay, and we're going to go j, image, pointer, arrow, width, j plus plus. Okay, and then we're going to read our pixels. Okay, now I give you what needs to go in the f read minus a couple of things. So you need to read the blue, okay, which is this here. Okay, so address of image, pointer, blah, pixels, I, j, dot blue. Then you need to work out what goes here and here. And then the last one's obviously your file pointer. I think I'm missing a bracket somewhere. Right here. Okay, so you need to work out what goes here and there. I don't want anyone to think that's a 0, so I'll just do it underlines. Okay, so think about what's the size in bytes of blue. You should be able to work it out based on this. And for this particular pixel, how many blues are there? It's obviously 1. Okay, so you can work out where the 1 goes. And you can work out how many bytes it should be. Okay, if you do this wrong, you'll notice straight away once you go and save the image. All right, and then you need to repeat this again and again 3 times, 1 for your blue, 1 for your green, and 1 for your red. Okay. Now, if we have a look at this, the first pixel is going to be 0, 0. Okay. So we've got 0, 0, which is this one here. Okay. And then we iterate inside. So we've got 0, 1, which is this one here. Then we iterate inside, and we've got 0, 2, which is this one here. We then exit this loop and I increments. So now we've got 1 for I, and then our J starts at 0. So we've got 1, 0, which is this one here, and so on and so on. And it should fill up the image into your data. So we're copying it from the image into our data. All right. Does that make sense? Once you've done that, you have your image. And that is incredibly powerful for you finishing this assignment. The next most important thing is to be able to save your image. So give me a thumbs up or yes, or a smiley face, or a fruit, a vegetable, an animal, a season, I don't know, a squid, in the chat, so you can understand it. I'm just going to have a little, I think we'll stop there for a little bit. A croissant. Let's have a 8.6 minute break. All right. So hopefully that made sense. And then we'll come and have a quick look at saving. And once we can do both of those things, you can actually check if you're doing it right. Because if you load it and then save it and it comes out as other garbage, that's good because you know you've got a problem. Okay. At this stage, just loading it, you're not going to know if it worked or not. Because you could have loaded it and it might be all perfect, or you could have loaded it and you've loaded it wrong and you've just got a whole heap of garbage in memory. So we need to be able to save it to see if you're doing this right. Once you've got that, you can start playing around with your image and changing things and doing the luminosity and trying flip it. And every time you try one of those things, you can print it out and see, did it work? Okay. So at this stage, we don't know if anything's working yet. Okay. All right. Let's have an 8 or 9 minute break. Maybe 10 minutes. Yeah. All right. Let's do that. All right, let's keep going. So now we'll look at the save function. So this is our second important function. As mentioned here, the two functions right at the start are the load and save, and then we're going to have a look at the free, and then the image ones are fairly self-explanatory up to that point. Pixels are a little bit of a problem-solving challenge. So now I've forgotten what we were doing. All right, so we're going to do save image. This function loads an image and then prints out the image about the file. So this is handy. We can't do this without. Wait. Well, there's a mistake I need to fix. That description's wrong. As you can probably tell, it doesn't load an image, it saves an image, but I will fix that. All right. So, well, you can test if it's loaded, because if it's loaded, you can print out the width, the height, and the size, and that's about all you can really test until you can save an image. Because yes, you can see if there's stuff inside of each of the pixels. You could, if you really wanted to, is get the values of that really small 8x4 image and then check it manually, pixel by pixel. It wouldn't take much effort, but saving the image would definitely be probably a better choice, because then you can just check it visually. It's up to you though. But yes, you could check it at this point if you wanted to. But it's much easier to save the image and then check it, because then you can just check it with your eyes and see if the image comes out correctly. Because the first thing we're going to do is just make a copy. So open and then just save it back directly into a file. And if that works, then the image should look exactly the same. And that's probably one of the best tests to do. But if you want to, you can print out the values and check if things worked. And if that doesn't work, that's the way you'd have to go about it anyway. All right, so create a copy of the file name from image and store appropriately using string copy. So we've already done that beforehand, so we know how to do that. So there's nothing new here. The only thing that you need to be aware of and you need to be careful of is the fact that this is not a pointer. So when you go and make a copy, okay, when you go and make your copy, just remember that it's now going to be image.filename, not arrow. Okay. You'll need somewhere to store the copy, so just make a suitable space in memory to store it, just like we did before. The steps are exactly the same, except for this time it's not a pointer, it's just a struct. All right. Then add the extension using string cat. We've done that already. And then create a new file using the file name with the extension, but this time it's for writing. Okay, and store the file pointer. If the file cannot be opened for any reason, print file cannot be saved and return 1. Okay, just like we did in the lab this week. Okay, so this is all looking very familiar. It looks very similar to our load and the stuff we did in the lab. Then In the lab this week, I gave you how to create the header. Once again, I'm going to give you how to create the header because it really doesn't aid your learning being able to extract headers. Obviously, it is helpful for your learning, but that's more for if you're concerned about how files work, not how C works. Okay. So basically, you're going to copy and paste this bit of code. Okay. And you can see the header information here. You can also see some of the stuff that we skipped before. Remember, we skipped a bunch of stuff. So we skipped the first 2 bytes. So we skipped these. These are constants, so we didn't need to store them. Then we grabbed the image size. Then we skipped 12. Okay. And then we grabbed the width, the height, and then we skipped these. And then we grabbed... No, we actually didn't grab the data size. We skipped the next 28. So we skipped all of these. Okay. The data size is dependent on the image size, so we can just calculate that. This is a little bit more complex if we didn't have that restriction at the start, which is the division restriction. And then we just write it to the file, okay, which is our header. Okay, so that's our header information there, and that will add our header. Okay. Once you've done that, all you need to do is let's make the... I really should just make the original canvas a bit bigger. But oh well. 114 meg. This file is quite large. Now, when it comes to writing our data to our file, it's actually not that exciting or different. Okay. It looks very, very similar to what we did before with our reading of our data. So create our iteration variables I and j, iterate from 0 to the height, iterate 0 to the width, write the blue pixel, write the green pixel, write the red pixel. So the only difference here is, well, the only 2 differences here is that it's going to be an F write this time, not an F read, and there's a dot there. And that's basically it. Your second and third arguments, so the element size and the number of elements, is going to be exactly the same. Your file pointer is going to be the same as whatever you created up here, but it's going to be an F write. Now remember, in the labs, even F write, it is the address of. Okay. And then close the file. Don't forget that. And then print image saved. Okay. So saving the image shouldn't be too hard once you've done loading. And once you've done that, you'll either get a... once you've done that, we can now actually go and do the next 2 functions. So, well, firstly, is there any questions about that? If not, just some emoji beginning with T. So if that makes sense, just, yeah. Tomato, yay. We got 1 emoji starting with T. Tiger. Hey, we got the turtle. That's going to be my one. Well, I got tractor. All right. So the next one is freeing. And this is a very small function, but it's an important function. And we saw how to do this with our ints. It basically is the exact same way with our structs. It doesn't make a difference if it's an int, if it's a double, if it's a struct, if it's any other data type. It still follows the same principle. We free all the rows first, and then we free the last thing last. So if we have a pointer to a bunch of row pointers, again, they're pointing to all of our columns. Drop. Okay, so something like that. Then we need a for loop, okay? And we need to free these first, okay? And then at the end, we free this guy, okay? So that's our free, and it's important that you do it in that order, okay? You need to work out how to use image. It's not a pointer in this case, so it's going to be image dot something, okay? And I'll leave that for you to solve. What are we doing? Oh, we're doing pixels. So I will give you that. Pixels, and then something after it, which I think I've given as well. All right. Does that make sense? Okay, so it's just the same as the ints, except for this time it's a struct, so you've got the dot there. Okay. And then we've got the very last function that we need. We could do print information image, but nah, that one's too easy. Oh, don't want that. Go away. I want this. All right. So the next recommended thing that I would tell you to do is this function here, which is this one. Save image copy. Beautiful. Beautiful. All right. So save image copy. This should be save copy. Oh no, wait. Did I do it wrong? That might be another mistake. Yeah, it should be save copy image, not save image copy. I'll have to fix that as well. Damn it. Save image, wrong description. Save image copy. Wrong name. This is the problem with doing everything in separate files. All right, so this should be save copy image rather than save image copy. But I'll fix that probably tomorrow morning or something. So this function loads an image and then saves the same image. Okay, it's not very exciting, but it tests everything works. So if you have an image called hello.bitmap, then this function should create a copy named hello_copy.bitmap. And the images themselves should be exactly the same. Okay, exactly the same. So if you look at one and look at the other, they should look exactly the same. And this is a great check. So first thing, construct a struct RGB image named image, gives you the code. Call the load image function and pass the address of image. And store what is returned from the function appropriately. So let me Let me find. Oh my God, what happened there? So load image returns an int. That int can be a 1 or a 0. A 0 means it was successful, and a 1 means it was not successful. Now I've lost where we're at. We're here. Okay. So when it says store it appropriately, you can store it into a variable like error number or something like that, like you did in the lab. Okay. And then you're just passing the address of image, which is fairly self-explanatory. Okay, it's a pointer to an image, so you're just passing the address of the image. If the image was loaded successfully, then do all this. If not, then you just return from the function. Okay, you can print an error message if you like, if that's part of your interface. Add the text underscore copy to the file name using stringcat. We've done that. Okay, we've done stringcat before. You know how to use it. Print image copied and then 2 new lines. As I said, if you want to change this to make it look pretty, as long as it's user friendly, it's not everything's just on the exact same line or everything's written backwards or upside down or it's trolley or something weird, then just go with what I've said. Otherwise, if you can make a nice user-friendly interface, go ahead. Okay, put stars. If you know how to use colors, you can use colors. You can do a whole bunch of stuff to make it look nice. And you can change what it says. This, you've got the creative freedom to make it look however you like. Call the save image function and pass the appropriate argument. Okay, so have a look at the parameter. There's only one, and this time it's not a pointer. So it's not a pointer, so we just pass the value. You don't need to worry about storing the value returned. If it fails to save, there's not much we can do at this stage, and it will tell us that it wasn't able to be saved. The other thing to note is that if it couldn't be saved, we still will need to free our memory. So free our memory by calling the free pixels function and passing the appropriate argument. Okay? And that there, if you do all that and it saves, the next couple of functions, well, 90% of the next couple of functions should be easy to play with, to test, to run. So I'll just get the list up here for you, and then we'll probably finish off there unless you've got any questions. So we've done main. Main is just a menu-based system, completely independent from any of the image stuff. Okay, all it does is a menu and calls some functions. We have the load image that we talked about, very, very important function. We have the free, which is also very important. This will tell you if you've done something wrong because it will crash. Okay, if freeing is failing, definitely you need to address it. Okay, it's not something that can be ignored. We skip the print information image. This just prints out the width and height and file size. That's all it does. You can implement that if you like straight away, or you can test if the other stuff works by having a look at the save. So we had a look at save. Save is basically the opposite of load. Okay, so you're creating the header this time rather than getting the information from the header. You're f-writing this time instead of f-reading like before. And then your save image copy is to copy your image. We then have 2 more functions here. The change luminosity, so that's changing the brightness and darkness. if we have a look at this, let me grab it up. If we have a look at this, you'll notice this iterate from height using I and width using J is very, very common. Okay. And you're just doing little operations on each of the pixels. Okay. And the luminosity one isn't very hard, and it's a really good tester. The next 4 are for removing the channels. So they're removing a color. Once again, these are just iterating. They're not too hard. Inverting just involves very simple bitwise operations. If yours are complex, you're doing it wrong. Okay, it's a very simple bitwise operation. Quantize involves a little bit more advanced bitwise, but it's a very small amount of code. My advice with the quantize is to sit down, draw it out on a piece of paper, and think about it before implementing. Because I've seen students that have written like 100 lines of code to do this. It shouldn't be very many lines of code. Okay. Quantize. That's not quantize. How many lines of code should quantize be? Around about 10 to 12 lines of code should do. Okay. It doesn't need to be that long. Okay. Maybe max 20 lines. Okay. If you are going to 100 lines of code, you're doing it probably wrong, or you're doing it in a way that's totally redundant. The flip, I don't give you any help with that. The document basically says you need to work that out. So definitely get a piece of paper and work out how you would move a particular pixel to another. This function isn't too complex, but there's lots of places to make mistakes. So you just need to be careful. And then the crop one, that is difficult. This is the one that I'm not expecting many students to get. Okay. So that's all the functions. And as I said before, the rubric is here. If you get stuck on one, just comment it out or just write not yet implemented and just move on to the next one if you like. Each one's worth between 5 and 8 points. So if one's not working for you, you can skip it and go to the next one and then come back to it. Okay. You only really need these first 6, and then from there you can really choose which ones you want to do in the groups of 2 or 3. Cool. All right. Any questions? Where is this? All right. How to enter the file name of image? Well, it depends. In last week's lab, we did it via the command line. If we want to enter it via the user, it's just as simple as a scanf and a string on execution. Yeah, so there's lots of ways to do it. We did one way last week, which was through the command line. But if you want to do it from the user, very, very simple. So if you but we've already covered that. So printf enter name of file. Yeah. And then scanf %s, and we can store it directly in our image pointer. We talked about this before, and that's going to be file name. Yeah, there's lots and lots of different ways we could do this, and this is why when it comes to the exam, there's no memorization, because there's lots and lots of different ways to do the same thing. No. So you cannot put the so if the images are in a folder, then the name of the file that the user needs to enter has to include the extension. Otherwise, if you knew that it was in a folder, you could use a string cat to add that to the file name, but we're not going to do that here. So you could do something like, it's going to be kind of difficult, but what you'd want is a string that had the extension. Okay, I did audio. What did you do? Folder. I'm thinking of last week. So you'd need a string that had folder in it, and then you'd need a string cat your file name to that, or the user enters the extension, which you'd expect the user to do that. You wouldn't expect the program to do that, because now by forcing the program to know that there's a folder there, it has to work only in your folder structure. Where if you expect the user to include the directory, then it will work anywhere. So I just leave it for the user. But no, you can't do folder/image-file name, because folder is not a variable. Okay. Hi. Because C would just see that as the syntax wouldn't work, because C would read that as folder as a variable, then it's got an illegal character, which is your division of a unknown type with a struct RGB image, which you can't do a division of. So it wouldn't make any sense. All right, any other questions? Are we all good? If you're good, do a emoji starting with S. Yes, exact copy of the image. If it's not, then you've done something wrong and you need to debug. And that's what that little tiny image is there. Yeah, so basically the user would have to enter the folder name and then a slash. But for this assignment, we're assuming they're all in the same folder. We all good? So see how you go with that. And then once you get that done, either it'll work or you need to use that 8x4 image to start debugging what went wrong. Most likely, So if your image comes out incorrect, so I'll give you this hint. If your image comes out incorrect, most people's problems will be inside of the for loop that does the f write or f read, okay, of the three different colors. Okay. Okay, so either the f read or f write. This is where most people will have their problem. And if that's fine, then go have a look at your header and just make sure you've copied and pasted it correctly. Okay. They're the two common places that you get mistakes, or where I see students make mistakes with headers and stuff like that. Because even in the audio one, that's where most students made a mistake in the labs this week, is with writing and reading. Because the compiler is not going to tell you if it's right or wrong, and it's a binary file, which we talked about in the lab at the start of the lab, and they're hard to debug. And it looks like things are working, but they're not really. So they're the two places that I would check is, well, three places: the f write, the f read, and the header. Cool. Any last minute questions? Or are we done? All right, I guess that's it then. Thank you very much. Good luck starting the assignment, and I will see you this week. And yeah, I will stay for a couple more minutes. Otherwise, thank you. All right, this is. Where do I stop this thing? Stop.